I want to talk to you now about the correlation between critical values and confidence intervals. A traditional method of statistics is, instead of finding those p-values because they were difficult to find before we had all of this technology, what we would do is we would find a few of the alpha levels, and then we would look at failing to reject or rejecting based on these values. So you would have a table that sort of looked like this, and these are the values that you would compare your test statistic against. So essentially what we're looking for is that when we have an alternative hypothesis that's one-sided, meaning like here in this case we would be looking at that the mean is less than whatever their value was. This is one-sided, which means all of alpha is on that one side. All of our alpha level that we're going to test it against is one-sided because our alternative hypothesis is one-sided. So what we want to be able to do is we want to be able to equate using, say, an alpha level of 0.05 or 0.01 and saying, well, what would be the appropriate confidence interval in order to make those two match up so that those two would in fact back up each other. So the one-sided hypothesis actually corresponds to a test with an alpha level of 1/2 of whatever the interval was. So say I had a 95% interval, 100 minus 95 tells me 5%, half of 5%, would be 2.5%. So that would be an alpha level of 2.5 or 0.025. But sometimes, again, you'll want to write it in this way instead, depending on if you're given alpha or if you're given the confidence interval. So as an example, if you have performed a one-tailed hypothesis test using an alpha level of 0.05, which is typically what we use and what you'll use in your case study, what confidence interval should I use to verify my results? Well, I'm going to use a 90% confidence interval, and here's why. If I take my alpha, I'm using essentially this formula, alpha equals 1/2 100 minus c, or in StatCrunch, MyStatLab, you might see it written like this, which is the exact same thing. Of course, I'm going to put in my 5, which is my alpha level that I used for the test. I'm going to solve for c to find the confidence interval. So I'm going to multiply by 2 on each side, and then I'm going to move that c over, and subtract the 10, and find a confidence level of 90. So if I'm doing a one-sided test, and I'm trying to find a confidence interval, a 5% alpha level corresponds to a 90% confidence interval. Now, if I'm using a two-sided test, which of course means that my alternative hypothesis was that the mean was not equal to whatever my proposed value was. Notice in a two-sided test, that should match up pretty well with the two-sided confidence interval, and that alpha is being split between each of the two sides. This calculation is much easier because it's just 100 minus the confidence interval, or the confidence level would be the alpha level. So if I did the two-sided test instead of one-sided, using that same alpha level of 0.05, I'm going to put alpha of 5 as a percent equals 100 minus c, and then I'm just solving to find c, which is 95, so I should be using a 95% confidence interval to check my hypothesis. So here's one for you to try. I want you to come up with what would be the appropriate, if I used a 95% confidence interval, what was the level of significance, meaning what was the alpha level that I used. So try this question and then press play to check your work. The first thing I would look at here is what would be my null and alternative hypotheses, because of course I don't know if it's one-tailed or two-tailed until I know what the alternative hypothesis is. Now, hopefully you noticed after reading this that this is not a means question. This is a proportion question like last week, which means my null hypothesis would be that p is equal to 0.08 because that's what I'm expecting. 8% of all chips are defective. So they're trying to do some things to decrease the percentage of defective chips, which means my alternative hypothesis would be that p is less than 0.08, which means this is a one-tailed test. So because it's a one-tailed test instead of a two-tailed, it doesn't matter if it's means or proportions, it's the same concept. If I used a 95% confidence interval, I'm plugging that right here. So 100 minus 95, and half of that is 2.5%. So they used a confidence or significance level or an alpha level of 2.5% in this question.